Alright, ladies and gentlemen, time for a little lesson about polar coordinates. We're starting something new. So you remember how the one time we had like radians and degrees, and there's kind of different ways to describe angles? Well, the same is true for polar coordinates, but polar coordinates is related to rectangular coordinates. So you know how like normally on a coordinate grid we have like an XY pair? It's like the x tells you how far to go horizontally, and the y tells you how much to go vertically. These are called vertical. They're called rectangular coordinates. So if I had the point like 2, -3, I'd have to go right 2 and down 3, and then that'd be my point. Polar coordinates are not this. Polar coordinates are another way of finding points on a coordinate grid. But instead of saying how far to go left or right and up and down, it tells you how far out to go from the origin, and that's called the radius, and then it tells you how many degrees around you go. So a quick word about degrees. You always start at 0 degrees, which is on to the right of the origin. I don't know why the right, just someone decided to the right was 0. So that's to the right. And then when you go a certain number of degrees, you go counterclockwise. Okay. And so if I wanted to graph this point 2, 75 degrees, I go out 2, and then I need to rotate around 75 degrees, and that's where my point is going to be. You may notice that we have our typical unit circle degrees here, and then we have these in-between lines. Well, the in-between lines are the ones in between. They're halfway between. Each line is 15 degrees. So if you add on 15 degrees, you get 15 degrees, 30 degrees, 45, 60, 75 degrees, 90, etc. Okay? So we're going to go out 2 and then around 75 degrees, which on this handy-dandy coordinate grid that already has these spokes going out, lets us know that the point is here. We got it. And that's it. That's how you graph polar coordinates. First number is how far out to go. Second number is how far around to go. And then you put a dot there. Let's try it. Let's try out another one. Let's go over this one. We got 4. So we're going to go out 4. And then we need to go around 19 pi twelfths. Well, you may have guessed that this 12 is related to the pi 6. It's half of a pi 6. Which matches up with our 15 degree mark. So this is pi twelfths. We need to go around 19 of those. So if we come out over here, this is 6 pi twelfths. And let's see, when you add... Sorry, that is not 6 pi twelfths. That is 12 pi twelfths. You think I could count right? Because remember, 1 pi, so 12 over 12 is 1. We need to now go 7 more, so 1, 2, 3, 4, 5, 6, 7. Hooray! Found it. Here is 19 pi twelfths. And I need to go out 4, so it's just here on this outer rim. So now we found it. We plotted the point. And that's it. That's how you graph polar coordinates. So like for you to do is go to your lovely assignment. We're going to look at that little graphic in a moment and see if you can do a few of these. Actually, just kind of pause and do all 6. It'll be pretty quick, and then come back. So pause and do that. Go ahead and graph them. Did you graph them? You did some graphing, right? Okay, let's get back to this. Okay, so let's talk about this graphic here. So polar coordinates are kind of interesting because they let you make things like this. So you got this cool like flower spiral thingy. Well, that's made from this equation down here, which is actually doesn't look that complicated, right? You got radius is 1.5 minus 1.5 times sine of whatever theta you're working with, and that kind of changes. So whatever you have in front of theta kind of changes how many petals there are or how many times it kind of loops as you go around. And that's a fairly simplistic looking equation. And it works. It makes these fancy looking things because it's in polar coordinates. So that's kind of the benefit of it, is you can do cool things like this. So the next thing you need to do is be able to convert from rectangular to polar coordinates and from polar coordinates to rectangular coordinates. Going from rectangular to polar coordinates is kind of interesting because if you imagine you have the point like, this one, 2 root 3, which root 3 is, hold on, what is root 3? Give me a second. Root 3 is about 1.7. So you're looking at about 3.5. So we go about 3.5. That's 2 root 3-ish, and then down 2. So let's say I have this point here. You need to convert this to polar coordinates. And remember, polar coordinates is concentric circles, right? So you need to figure out how far out it is and how many degrees around you had to travel. And this thing is a mess. Here, let me kind of do this. So let's say we have our radius. You need to figure out how far out it is, and you need to figure out how many degrees around you had to go to reach it. Each of those is a different step, a different thing to figure out. Let's start with the radius. So to get this radius actually isn't too bad. You should imagine you got a lovely little right triangle here. This is 2 root 3. This is -2. And then you can find your radius. Just Pythagorean theorem, so we're going to call radius squared is, 2 root 3 squared plus -2 squared, right? A squared plus b squared equals c squared, that kind of stuff. So the radius is going to be the square root of 2 root 3 squared plus -2 squared, and you'll get an answer from there. Let's just figure that real quick. So actually, I'm going to show you what the Desmos online calculator does. You can use this. It's really handy. Just do desmos.com/scientific and you get this. I'm just going to do what's inside the square root first. So let me clear all this up. Let's do the first thing. 2 square root 3. Do some closing there. I need to square that plus the other one was -2, which I'll need to square. And we get 16, and I already know the square root of 16 is 4. Okay, so we got our radius is 4. Radius, I'll do square root of 16, which is 4. Nice. So we got r is 4. So we got 4, comma. Now we need to get the theta. We need to get what the angle is. To get the angle that's in here, you need to set up a trig equation that uses these 2 points here, which that is opposite and adjacent. So we're going to use tangent. So tangent of theta would be -2 over 2 root 3. Negative there. And so if I want to get my theta, I just need to do inverse tangent of -2 over 2 root 3. Which, if you're looking at your notes, is in the notes. All right, it's y over x. And so I just put the y coordinate over the x coordinate and got it. Okay, so I'm going to do that and jump over to my Desmos Calculator. If you have a physical calculator, you can do inverse tangent. Works great. But I'm going to go to function, which is here on the bottom left side. You got main, ABC, func. You want to do function, inverse tangent of -2 divided by 2 root 3, like that. Close it, enter, and we get -30. And my thing's in degrees, so we got theta is -30 degrees. Nice. Well, hooray, we got a thing. But the thing is, we need to make sure our angle's in a positive amount. And so we're going to look at this little note here. It says your angle may be in the wrong quadrant. Double check that it's pointing in the right direction. So if you think about a normal unit circle, going down 30 degrees would put this in the right place. But let's make it a positive amount. Do a positive coterminal angle with it. And so we'll say it's 330 degrees. And so that's what we'll put in here. We'll try and keep our angles to be positive and our angles positive. All right, so that's that process. So hooray, we converted it to polar coordinates. let's jump over to this other one. It's got some weird numbers in it, which if I were to draw a little sketch, it'd be going left some and then up some. I know this is not the exact point, but I'm just going to put it here. And so yeah, that's where it is. So I'm going to now get my radius just by squaring my x-coordinate and my y-coordinate and adding them together and getting the square root. So radius is that. I'm actually going to just use my hand calculator to get this, because I can. Divide by 2 plus. I get 9. Nice. Which means my radius is 3. Hooray. So I get 3, comma. Now I need to figure out my theta, which is going to be the inverse tangent of y over x. So 3/2 over negative 3 root 3 over 2. It's kind of a mess, but use parentheses. Yeah, like in the calculator, put parentheses over all this stuff here. So I'm going to do that again. I got inverse tangent of the top thing, 3/2, divided by parentheses around my bottom thing, negative 3 root 3, divided by 2, close parenthesis, and I get negative 30 degrees again. Okay, so we got this, but we need to make sure we double check that it's pointing in the right direction. It's just kind of how the calculator works. It only gives you angles over here, just that's because trick stuff. There's trick stuff where reasons why it only gives you angles over here. It's because these ones are the exact same here when you do tangent, and whatever. Yeah, so this gave us an angle that's down here. Well, this is just down 30 degrees. This is in the wrong quadrant. We need it to be over here. And since the tangent values over here are the same ones over here, it's just giving us this angle. And if we want to get it over here, we're just going to add 180. And so that's a thing you can do to get it in the right quadrant. You can add it 180 so it's in the right place. So now we're looking at theta is 150 degrees, just like that. And hooray, we got it. It's in polar coordinates. So there you go. That's how you go from rectangular to polar coordinates. Not too bad. So let's have you go to your assignment and see if you can do a few of these, that are 7 through 12. Put them in the formulas, get your things. The kind of tricky part's the angle, but try a few of them and get them figured out. You'll get there. Pause and try it out. Go ahead. Try it. All right. So now we're going to go the other way. We're going to go from polar to rectangular coordinates, which if you get something like 3, 120, if you were to graph it, right, it ends up over here, and we have this radius of 3. Well, you can get the rectangular coordinates just by turning it into a right triangle, and you figure out the horizontal and vertical components of this right triangle. And it's pretty easy to get, because if this is your theta, then theta is opposite over adjacent, which is going to be something over 3, and then you can rearrange it, equals sine of 120 or whatever the angle, let's say it's 120. And then you can rearrange, just times by 3, and you can get your opposite length just by doing sine times your radius. And the same works for the horizontal component, but you use cosine. And so really, if you want to get the x-coordinate, you just do r times cosine. And if you want the y component, you just do r times sine. So it's actually pretty quick. So if you want x, that's going to be 3 times cosine of 330 degrees. And if you want the y, you do 3 times sine of 330 degrees. And I would like it if you use the exact values on these, because sometimes we do things like sine of 330 degrees or cosine of 330 degrees. You can get things that are like this infinitely long decimal thing. Don't do that. Just get the exact values for these, and it'll simplify pretty nicely. select this one. You can look on your unit circle, go to 330 degrees, and figure out what the, what is, sorry, 330 is going to be over here. And so this is going to be 1/2 for sine, well, negative 1/2, and then root 3 over 2 for your cosine. So this becomes 3 times root 3 over 2, and this becomes 3 times negative 1/2, which will give you a negative 3/2 for the y, and then 3 root 3 over 2 for your x. And so altogether, you get 3 root 3 over 2, comma, negative 3/2, and we got it. That's the those are the rectangular coordinates for these polar coordinates here. Yeah, that's kind of the process. Just do radius times sine, radius times cosine of theta, radius times sine of theta, and you get those figured out. Just use your unit circle to convert things. So yeah, if I was going to do this other example, I know my x is 3 times, cosine of 7 pi 6, and then my y is 3 times sine, sine of 7 pi 6. Again, I want to use the exact value, so I'm going to do 3 times. Well, if I don't have my unit circle handy, I can do a quick sketch. I know this is 6 pi 6, this will be 7 pi 6, so I got a 30-degree angle here. So this is going to be negative 1/2 and negative root 3 over 2. And so this one is going to be 3 times negative root 3 over 2. And this is going to be 3 times negative 1/2, again, actually. So we got negative 3 root 3 over 2 and negative 3/2. So altogether, negative 3 root 3 over 2, comma, negative 3/2. And those are my rectangular coordinates there. So actually going from polar to rectangular is not as bad as going the other way. But yeah, that's kind of the process. So go over to your assignment, try out the last ones, see if you can get them converted into rectangular coordinates. And good luck.